Welcome to my talk. It's great to be here at SANS. So we will discuss today about cross-data source correlation of the Golden SAML attack, which going to be an interesting thing for us for doing with exploring different telemetry for different data sources. So let's get started. So today's journey will start with the risk motivation, and here I have a camera. Okay, so it will start with the research motivation, the research questions that we conducted during the research in order to understand better all the relevant topics that we want to find out. The next will be Active Directory Federation Services crash course. We'll be discussing about what is ADFS, why we need it, and all the relevant background knowledge that we need to gain in order to understand how the Golden SAML attack works. Next, we'll discuss about the Golden SAML attack itself. So how we can exploit it, what the relevant properties that we need to gain in order to exploit it. Later, we'll discuss about security products, different security products that are relevant to detecting it, or at least claiming that they can detecting it. And we kind of see different categories of those things. Next, we'll discuss about cross-data source correlation detection, how we can take telemetry for different data sources and take him into one picture of detection. And in the last slides, we'll discuss about threat hunting practices, a few slides, a taste of things that you can do today in order to reliably hunt for exploitations. So a really quick, who am I? So my name is Yonatan, I'm 24 years old, I'm from Israel. I have some experience in cybersecurity for a few years. Today I'm a threat hunter at Hunter's Team Axon. We're doing some cool stuff, researching sophisticated threats and researching unique attack vectors. And yeah, let's get started. So how we got here, the research motivation. So this kind of research questions that we conduct during the research, and I think it's not all of them, obviously, but kind of the general ones that I think will be really interesting to discuss on. The first one is the industry awareness of the attack. So how either defense and offensive team are aware of this technique, and from a defense side, how security analysts, how incident responders know how to deal with it, how it works. And from the offensive part, how red teamers actually aware and know how to simulate it. So it's not only about red teamers to know that this exists, but how they really know how to actually exploit it and practically exploit it. So we were curious about this question. The second one is existing protection. So do security products have us covered today against this technique? And I think this one is kind of related to the first question, because we know that vendors allocate relevant resources based on the popularity of attacks. And this one isn't so popular. It doesn't mean that it doesn't exist on the wild. Maybe just say that we do not detect it, kind of food for thought. And the last one is, can we hunt and detect better? Can we take the hunter's approach of combining different telemetry from different data sources and simply have a reliable way to detect? Okay, so let's speak about Active Directory Federation Services. Kind of a really quick crash course for us to understand better all the things that we'll discuss on. So what is ADFS? So ADFS stands for Active Directory Federation Services. It's actually an IDP that developed by Microsoft to allow us to enable a trust between on-premises and third-party applications, aka service providers. And the need for it was the race of cloud applications and applications that do not manage within the Active Directory. So a single place to be able to authenticate to all of the applications with your on-premises credentials. So what it will do basically is to provide us an SSO authentication solution with our Active Directory credentials. You probably noticed that the last bullet is in bold, and I did it by purpose because it's really important to know that ADFS isn't a managed solution. Today we all know SaaS and all the idea behind SaaS, but ADFS is completely the opposite. So ADFS is an unmanaged solution that the organization needed to maintain within the on-premises environment, which is the engineers or analysts that maintain, IT engineers that maintain the ADFS within the on-premises environment, which means that the on-premises, which means that the servers exist within the on-premises, just a server. Now let's examine ADFS authentication flow, a legitimate authentication flow of ADFS. So I will take Office 365 as an example here, just because it's a really common one to explore. But it can be any service provider, right? It can be G Suite, it can be Slack, any applications that you configure to your ADFS. So it will start with our request to the service provider. In this point, we need to keep in mind the service provider do not have any idea what is the credentials of the user, right? He simply knows that it is a federated domain which needs to be redirected to the ADFS that configured to it. So in this step, we only provide the federated domain with the ADFS server. Now, the next step is a redirect to the ADFS reverse proxy. So the ADFS reverse proxy, as the name suggests, is basically a reverse proxy that give us the option to send secure packets to the ADFS, or more specifically to the ADFS endpoint, which are the, you can think about ADFS endpoints as APIs for specific objects. And it's just provide us the ability to authenticate from external network with the internal ADFS, with a secure way. So in this step, we'll put our credentials to the ADFS reverse proxy, and we'll move on. And now with this step, we come to something that's named the claims pipeline. So we will provide with the ADFS with the claims, which are based on the attributes that we supplied in the service provider. And it will generate issued claims that at the end will be encrypted with some kind of cryptographic operations and signed to a SAML object assertion that will be provided back to the user. So just to put it in a nice word, what the ADFS will do is basically to take the credentials from the user, take the relevance attributes, validate them against the Active Directory, and somehow, we will see how in a minute, he used something to cryptographically encrypt this assertion and send it back to the user. Now, after we have our SAML assertion object with the client, we will be able to authenticate to the service provider. So this is kind of the legitimate authentication flow of the ADFS. Okay, so now let's start to look on how Golden SAML attack comes in, right? We know at this point how the ADFS authenticate, and we will have a better, we'll be able to understand how it works, how the attack works. So what Golden SAML basically does is the ability to impersonate to any identity in the federation, to any identity, to any service provider that configured to the ADFS. How we do it? You do it with basically creating a fork SAMLs based that signed with the stolen ADFS certificate. So we will discuss about ADFS certificate in a minute, do not worry. But what we should keep in mind is that in this way, we basically can impersonate to any user in the federation if we put our hands on the ADFS certificate. So you remember that I say that the ADFS lives on the on-premises environment, but it's a server, basically. So in order to store the ADFS certificate, we will need to be on the on-premises environment, obviously. In some of the methods, we will also need to be on the ADFS server itself. And we'll need to export the ADFS certificate, export the relevant claims that are required to the specific service provider, right? Service providers request different claims. And with that, we'll be able to create our ultimate fork SAML and to authenticate to any user that we want in the federation. Now, it's very important to mention that Golden SAML isn't a vulnerability. Okay, it's simply a design flaw. And it's really important to mention it because it's not a vulnerability that has like a CVE sign. It's simply a post-exploitation technique that allows us to have a really impressive way to be able to do really bad stuff for a really long time. And the reason for that is that we know that the cryptographic operation happens in the ADFS by the ADFS certificate, allow us to authenticate to any service provider. So if we will put our hands on this certificate, we simply be able to be ADFS. A good equivalent is Golden Ticket that I'm sure that all of you know, which exists on the same thing, right? Our ability to stall the KRB TGT and then sign any TGTs that we want and be any user that we want in the Active Directory. So this one is simply with the federation to be able to authenticate to any third-party applications in the federation. Okay, so now let's discuss how we can put our hands on the ADFS certificate. So there are plenty of methods. We'll discuss some of them in the talk, but those are the main ones. So the first one will be with the exportation of the token signer certificate. So in order to do so, we will have to be the ADFS service account, which is the service account that created when you create your ADFS server, basically. And we will need to open a named pipe to the WID database. So the WID database is basically the database that stores all of the ADFS settings on the ADFS server. It can also be configured to the external SQL as well. Now, after we will open a name tab to this WID database, we will be able to query a table named server settings, and we want to extract a specific element named encrypted PFX, which is under the sign-in token. So the encrypted PFX is basically the ADFS certificate blob, but an encrypted blob. And we'll discuss in a minute how we can decrypt it. So as I said, the blob that we extracted in the previous slide was encrypted. It's not the ADFS itself. It's not the complete ADFS. So we'll need to decrypt it basically. And we can do it with a thing named ADFS DKM, which is the key that can decrypt the token signing certificate that we discussed in the previous slide. So in order to do so, we can do so without the ADFS service account. We can just do it from privileged user in the Active Directory. We'll need to query the ADFS default container and go with the container of the group GUID object from the DKM settings. So from the DKM settings that we described in the previous slide, there is another element which presents the GUID object of the group of the DKM. Then we will need to look for another thing. So in this step, we can go to the container of the group GUID, but there is two objects under this container. One of them named crypto policy. The other one is kind of a random string, which always change in different systems. So we will want to look for the other one that isn't crypto policy. This is the object that we're looking for. And from that, export the tabnel photo attribute, which holds the ADFS DKM. This is kind of an example how we can do it really, really quick. We can use the get AD object from the Active Directory module, filter for object class, which isn't named crypto policy. And if you look on the LDAP, we read it from right to left, right? It's TID. We will go with the ADFS container, the ADFS GUID group, and we'll be able to present the ADFS DKM key. So really, really simple, basically. Okay, so having said that, we should keep in mind that there is two other options that we can do that isn't involve our need to the ADFS service account necessarily. We can use to export the ADFS certificate directly from the ADFS certificate store. There's a couple of ways to do it. One is with tools that can fetch Crypto API, such Mimikatz, for example, which has a nice module for exporting a certificate in Windows. The other one is exporting it directly from the CertLM MMC, which means that we can simply export it directly from the CertLM GUI. If you're asking why, is that it's related to the configurations that you're doing when you create certificate in the Active Directory CA, in the Active Directory Certificate Authority. So when you're creating a CA, you can have the option to configure it to be exportable. And if you do so, you'll be able to export this certificate from the CertLM GUI itself. It's another good opportunity to call for a posture recommendation. Do not configure your certificate to be exportable because you will do your attacker life really, really easy, basically. So another recommendation. So we're on a good track to create our Golden SAML, and now we need to adjust the right claims. So we need to be able to create relevant claims that were created if we, had the legitimate claims pipeline. And those are the ones that the service provider will expect to get. So it will be different from service provider to other. In this case, it's case of O365. There are a couple of requirements. One of them is the UPN, which is basically the user that we want to authenticate with. So it's important to keep in mind that when we create our Golden SAML, basically we'll need to have the right claims for the specific service provider. So let's speak about what makes it so bad. What is the thing with Golden SAML? So there are a lot of reasons, but those are the main ones. So the first one is MFA bypass. And we should keep in mind here that MFA isn't really relevant here at all, because the way that MFA works in ADFS is with adapters. We won't dive into adapters in this talk because we're limited in time, but what you should keep in mind is that the MFA authentication method will happen before the cryptographic operation of the SAML assertion object, which means that MFA are completely useless here, right? The next one is long-term persistency, and it's kind of our way to keep using this method if we export the certificate. And when we're creating certificate, usually the certificate will be with an expiration date of 1 year, 2 years, 3 years. We saw cases of 4 years even. And basically it means that if the attacker put his hands on the certificate, he will be able to use the certificate for as much as the long of the certificate lives. So it can open the doors to really long-term persistency. The third one is a high impact. High impact means that we are able to authenticate to any user in the federation and to any service provider in the federation. We simply can be anyone that we want. Another thing to keep in mind is that passwords are not relevant here, right? So if the user will change his password, if I still, has this certificate that I stole, I can still be able to authenticate with it. The last one is difficult to remediate. So difficult to remediate, I won't dive into the incident response remediation step that you need to do specifically, but you need to keep in mind that in order to recover from this attack, you will need to rotate the certificate of the ADFS, which is kind of hard when you have farm of different ADFSs, and you also need to keep in mind that you will cause problems with users that authenticate and use the authentication IDP while you're doing it. Now let's speak about security products challenges. So when we started to research it, wasn't only about know how offensively we should do it. We also wanted to know how security products today deal with it. And in order to do so, we basically started with split it to two main categories of security products categories that we thought and heard that maybe think that they can reliably detect it. And we heard those from colleagues, from customers that saying that maybe those components will be able to detect exploitation of it. So the first one is the service provider security layer, which is kind of your Office 365, your G Suite, all of those service provider, with a claim that they can maybe detect, for example, against real authentication, like legitimate authentication SAML. We'll talk about it in a minute. And the second one is endpoint security products. So how security products that lives on the endpoint can detect the exploitation of the certificate itself. It makes sense, right? Because we at the end need to export the ADFS certificate from the ADFS server, and if it has an EDR agent on, we probably be able to detect it. Let's start with the service provider security layer, and we spoke about it all over the talk, but we should keep in mind that those products are completely blind to what happened in the authentication, because all they know is that they have a trust with the ADFS. And if we, as attackers, have the certificate that signed for those objects, we can simply be able to authenticate to the service provider without its ability to know that we are not the real ADFS. So it's really important to keep in mind that they are completely blind to it and they are not relevant to detecting it. Now let's move to endpoint security products, to EDRs. We love EDRs. We're working with EDRs from both sides, defense and offensive. And when we started to research, how the EDR behaves to different, phases of the exploitation and the exploitation of the certificates, we always start easy. We always start with easy steps to conduct. And I want to share with you like really quick situation that we saw on leading EDRs that we checked. So we start with a compiled version of ADFS dump, which is a tool that Mandiant developed, a really good tool that export ADFS certificate. It basically used the same properties that we described on the first method that we discussed, like exporting the signing token from the ADFS settings. We basically run it and we got a process-loaded malicious model. And it was like really fun to us because we reviewed the source code line by line and we couldn't find any external, references to not generic module or assemblies that can, be presented or represented to the EDR as malicious. So simply obfuscate the classes, remove the metadata, and there wasn't any detection. It was funny. We understood like in a couple of minutes that this was really, weak static detection. And without diving into it, we should keep in mind that most of the EDRs do not have the ability to monitor for open name pipes and do not, provide relevant telemetry for holistic detection. Obviously, we didn't check all the EDRs in the world. We don't say that all the EDRs do not provide it, but with the leading EDRs that we were able to check, we bypass them really easy. Another thing to note is that you should keep in mind that if someone stole your certificate and you install your EDR afterwards, it means that in theory someone can still use a certificate and creating fork samples while the EDR is deployed. Basically, it's only relevant to the exploitation part. Now let's speak about cross-data source correlation. This is why we're here today. So in order to do so, we should examine like different forensic phases that we have for telemetry when the authentication happened. So the first one is a Windows event logs 1200 that is created when a successful authentication with ADFS happened. And this one provides us a lot of relevant attributes about the relying party, which is service provider, the username that we're authenticating with, even the ADFS endpoint, a specific ADFS endpoint that is relevant, and all of the related artifacts. The second one is that the log that created in the service provider. So every service provider today, provide a basic telemetry for authentication. And in this example, we see here for Azure sign-in logs that we checked for Office 365. So basically, it means that if we will see an authentication to Office 365 or to Azure with the telemetry that they provide, and we didn't see forensic artifacts in the ADFS itself that says that we authenticated, we probably can assume that someone is missing with our certificate. And this is exactly it, right? With a God view of looking on different artifacts from different data sources, we can assume that if someone had this, telemetry of authenticated with a service provider and didn't have an artifact in the ADFS, it simply means that someone is messing with us. Now let's speak really quick about threat hunting practices. We do not have much time left. So the first one is really quick, pretty easy one. So we should start monitoring for ADFS service account logins. So when you create your ADFS service account, when you're creating the ADFS server itself, it always configured to be logging with logon type of 7, service login. If you see logins of ADFS service accounts with RDP or something else, it's pretty odd and you should check it. And if it will found out to be your IT guy, you should, explain to him that he shouldn't do it. It's not secure and it's really something that you do not recommend. You don't want your ADFS service account to be, on some else SaaS across different workstations that you have or servers. In order to identify the ADFS service account, you can check for the user SID that is loaded the binary Microsoft Identity Server service account, which is the binary of the ADFS service itself. The second one is pretty funny one, is the ability to scope the ADFS service account behavior of sending a suspicious DKM LDAP to the DC. Now, this is interesting because I said in previous slides that you do not need to be the ADFS service account in order to do this. But the thing is that most of the tools do this, the exploitation of the certificate and the DKM in the same time with the ADFS service account context. So in this case, you will be able to catch those tools and gain profit. So what we learned here really quick, we discussed about Active Directory Federation Services overview. We spoke about the Golden SAML attack flow and properties, how it works, how we can exploit it, how we can take a certificate and creating fork SAMLs. We discussed about the challenges in detecting heuristic exploitation with single surface security products, EDRs, service providers. We discussed about cross data source correlation, how we can take different telemetry, from the endpoint, from the service provider logs, and correlate them into the attack story. And we give a taste about threat hunting practices on ADFS servers that we recommend to start doing. And that's it, guys. Thank you so much. You have some good references here that you can check. I really recommend to anyone that's curious about ADFS. I will say that we also share a blog post on our Hunters AI site that will describe a lot of different threat hunting practices to conduct on ADFS, more to the ones that we described because we are limited in time. So thank you, guys.
Well, thank you so much. Really appreciate this. And especially bringing this content to the SANS community. ADFS is something I think a lot of folks are struggling to really understand. And as you pointed out, right, threat hunting around and performing threat hunting and detection of Golden SAML is critical, right? Because once you have that signing certificate, game on, man. It's a long-term, real world long-term impact. So really appreciate this. Folks, if you have questions for Yonatan, please drop those into the Slack channel. He'll be over there shortly to answer those questions for you.